Any questions?
Do you know when our first exam is? Do you know when our first exam is yet?
Yeah. Do you want me to make it up
No, don't make it. Just
next Monday? No?
that's it.
All right. We're about to do a test level problem, I believe. So we have A, B, C. Jeff, notes of time would be easier than rethinking everything. Alright, so I did put it here. F, G, I. That is it. E, I, F, and H were on the flat surface. Let's see, F was the last movement. It was, yeah, so it's completely on the flat surface in these regions right here. So I'm just gonna put up just a notation right there to. All right. I'm gonna go through the similar exercise that we did before, except obviously more complicated than a ball being thrown in the air. So first off, A between A and B between B and C, C and C and D. Am I gonna run out of room here? And C, D, D. Granted, but functional. All right, so we'll start out with position. What is position?
Where you are in reference to the origin.
And where was the origin?
Right, at the corner of E and I.
So I made it here.
Yes.
Okay. So I recommend when you're doing this, I find it sometimes helpful just to establish the zeros first off. So since it's defined as 0 is at time E, the object is at the origin. So E is 0. And at I. And the big advantage of establishing your zeros is you can only go from plus to minus or minus to plus without, you have to code through 0. So we've established 3 regions now that are either going to be plus or minus. I can't remember if I established it before, but we will make it to the right positive. Y is to the right positive. That's not why. And you also might be going towards the origin, depends on where you are in it. Y is to the right positive.
Because it's to the right of 0.
Not all of it. At point A, I'm to the left of 0.
It's where the ball's traveling. It's where the ball is traveling.
No.
Time.
No.
Because that's what it tells us.
Oh, more specifically than that? Who says it?
The arrow. The I hat. You.
Yes. To the right is positive because I said so. If you'd been doing the problem, you could have made to the right positive, and then it'd be because you said so. Or you could have made to the left positive because you said so. it's the direction, now, the reason I'm doing positive to the right and making it for everybody here is just so that everyone's answers would be the same. If somebody wanted to make to the left positive, then all your pluses and minuses would flip. When I first started doing these problems, I did not assign that, and some people actually, they did two different directions and it just became a nuisance to grade. All right, so we have established zeros. So what about from A up to E? Positive or negative?
Negative.
Negative.
Yeah, because I'm on the negative side of it. So it's negative all along here. What about from E to I, in between E and I?
Zero.
It's gonna be positive. I think somebody had said it over here, it was positive, solved. Because throughout this entire journey, this part, I'm to the right, I'm to the plus side of the origin. So it's gonna be plus all along there. And what about after I, but up to J?
Negative.
Yeah. Now, in this case, between the zeros, it went from negative to positive to negative. It's not always gonna do that, but it definitely is doing it in this case. Questions about position? All right, displacement. First, let's establish where displacement is zero.
At B.
Pardon?
At B.
Why B?
Because we determined that's where the starting point was.
It does not start at B.
C. Never mind.
It does not start at D.
C.
What is the first time in the problem?
Oh, A.
A, yeah, it starts at A. Is the box at that position at any other time? Say it again?
C.
C, yeah. So it's zero at A and at C. Now in a test, I provide the grid for you, so you wouldn't have to draw it as badly as I'm doing it. All right, so now, in between times A and C. Because when it starts out, it's initially going up the ramp, it goes to B where it stops, turns around, and comes back down.
Be negative.
It is indeed negative, because I'm on the negative side of my starting point. And then from C to the end of the problem. Questions about displacement? All right. Red shows up. All right, velocity. Where's the velocity zero?
B.
Yep. That's the turnaround point, so B
And G.
and G. And there's one more. Yeah, J, it stops also. Part of this is I'm assuming that you remember, or you at least wrote down from last time. But J is the point where it stops and it's about to turn around, but we ignore the problem. We don't care what happens after J, but at J it's also zero. All right. What determines the sign of velocity?
Direction.
Of okay, direction does decide whether it's positive or negative, but how do you know when velocity is positive or negative?
Based on zero origin.
No.
Speed.
Pardon?
Speed.
Well, that's the magnitude, is the other part of it. There was even a question on the lab yesterday where it said, in general, when is the instantaneous velocity positive?
When the slope is positive?
Pardon?
When the slope is positive?
Slope of,
The graph, the line.
which, there are lots of graphs.
Yeah, there's lots of
Oh.
lines.
The starting point, whenever it's moving in a positive direction relative to the starting point.
No, not relative to the starting point. Just cut that part off and say it again.
Moving in a positive direction from the
That's-
starting point.
Nope. Cut out the starting point part.
It's moving in a positive direction.
There we go. Velocity is positive when it moves in a positive direction. It has nothing to do with where it is. It doesn't matter where the starting point is or where the origin is. It just matters which way is it going. So from A to B, which way is it going?
Negative.
Between B and G, which way is it going? And from G to J?
Negative.
So what I was looking for, Nathan, was direction of movement. And now the tough one. We can get some of these simply enough. There are a couple of different approaches to it. Approach number one. I know that if acceleration and velocity are the same sign, it's going to speed up. If they're slowing down, it's going to be, there'll be opposite signs. So we can just do a first run by that. I'll go over the other methods in just a moment. So from A to B, speeding up or slowing down?
Slowing down.
Is that what you said? Okay. So it's slowing down, so my acceleration would be positive because my velocity is negative. So it's slowing down. What about from B to C? Okay, so it's speeding up, so same sign. At C, is it still speeding up at C?
Yes.
Keep going. When does it stop speeding up?
At G.
Well, definitely not speeding up at, well, it slows and speeds up at G.
J,
Pardon?
J,
It stops there too. But as it's coming down the ramp. There is a point before G,
I.
Between 9 and 8.
or coming this way, E. Time
Oh, yeah.
E is the time at which it's coming this way. So once it's completely on the flat level, it's gonna be and there's no friction there. The velocity will be constant. So from E to H, including, E to F, my acceleration is 0. Oop, I went too far. So E to more pluses in there. E to F, it is 0. And then on the way back, H to I. Because there's nothing driving it. I mean, it's moving because it was already moving. But between E and F, it's not going to speed up or slow down. All right, so before it gets there, it is going to be speeding up until it gets flat on the flat level surface. So it is positive acceleration up until E. Now from F to G, is it speeding up or slowing down?
Slowing down.
So F to G is positive, so that would be negative acceleration. From G to H, speeding up or slowing down?
Slowing down.
Speeding up.
Speaking up.
Speeding up.
I hope so. G to H, because especially at G it stops, so if it's slowing down after that, it doesn't continue the rest of the trip. So it's speeding up, so it'll be the same sign. Then you get the 0 spot, and then from I to J, speeding up or slowing down?
Slowing down.
Slowing down, so since my velocity is negative, my acceleration is positive. Now, obviously, there's some gaps here that we need to fill in. So let's fill them in. At A, it's already moving. I mean, basically, it can only go from positive to negative at zeros. So unless there's a 0 on that ramp there, it's got to be positive. At B, it's still positive. That's a turnaround point. At G, it would still be negative. And at J, positive. This is probably the one that causes most arguments. Because we're talking at the instant that it stops. We're not talking a moment after it stops. We're talking J is that brief instant in which the object stops. So the velocity did change in that moment. All right, all this is well and good, but that particular thinking through it doesn't work for everybody. So questions on this before I tackle this a different way? I will point out now. Let's make sure I actually did hit record on this. I did. Notice that no two rows are identical. If on the test, for example, or on the master set, you have two rows that are identical all the way across, I will assume you don't know what you're doing, and I will give no credit for one of those two. So, all right. That's to prevent I can't remember the difference between position and displacement, so why don't I just put the same answer for both of them and see what I can get out of that. They will be different. All right. Another way of looking at the exact same thing with acceleration. I'm just going to make up a number here. So let's say at A, I've got, it's going at 40 meters per second up that way. Now, granted, it's at a slope here, but it's going to the left, so I'm going to call it negative 40. At B, it's, oh, that's rather extreme. All right, let's make it negative 10. At B, it's 0. Then it speeds up again, so whatever it lost here, it would gain here, so that's positive 10 meters per second. It's still speeding up, so we'll make that 15 meters per second. Still speeding up, and so let's say it's going at 20 meters per second when it gets to there. It'll stay at 20 meters per second to here. It's 0. There is friction over here. That's what the symbol right here means. Now on the test, I would just say that there's friction there, but that's the shorthand. It's going to speed up, but it won't be going as fast as it was before, so we'll just say 10 meters per second. 10 meters per second here, and 0 meters per second here. Now, if you thought about it enough, you would realize that there's some unlikely numbers there, but hopefully you get the gist of when it speeds up and slows down. So now let's take a look at the change in velocity. So when I go from negative 10 to 0, what is my change? When I go from 0 to positive 10, what's the change?
Positive 10.
From 10 to 15?
Positive 5.
From 15 to 20?
Positive 5.
From 20 to 20?
0.
From 20 to 0?
Negative 20.
0 to 10?
Positive 10.
Positive.
Wait, something's off there.
Yeah.
We go from 20 to 20. Oh, that's going to the left, negative. That's negative, okay. So 20 to 0 was negative 20, 0 to negative 10,
Negative 10.
negative 10 to negative 10,
Zero.
negative 10 to 0.
Positive 10.
So my acceleration between A and B is positive. Between B and C is positive. Between C and D is positive. Positive. Then I have the zeros, negative, negative, zeros, and then positive again. That's acceleration. Change in velocity over the change in time. Questions about that way of looking at it? Because there is another one, another way.
Will there be numbers?
Pardon?
Will there be like numbers on meters per second?
No.
Okay.
No. You would, based upon the context, supply your own numbers. Well, I don't know if that tone came out right. You could supply your own numbers.
No.
All right, the other way of looking at it deals with forces, and granted, which is chapter 4. But if you think about what's acting on these objects, there's the force of gravity. The whole reason that it would, at G, it would slide down the ramp is because of gravity. Wow, I would gig you if you said that later. Is because of the force of gravity, or its weight. So there's a force of gravity acting in that direction. Friction doesn't like the way things move, so friction is going to be acting this way. Well, as it's going up the ramp, I still have the weight acting back that way, and friction is still acting against the way it's moving as it's going up the ramp. Here, there's also a force called the normal force, which is perpendicular to the motion. Along here, I have weight acting straight down, and I have the normal force acting up. The normal force is just a support force. It keeps objects from falling. The reason you are not falling onto the floor right now is the chair is pushing up on you.